Hey, what's going on, guys? In this video we are going to see how to solve a basic transistor circuit using mesh analysis method. Now here what we are going to do is we are going to find out this V sigma voltage, and also we are going to find out what is VCE voltage, and then we are also going to calculate this IB current, and that's all it is. Now let's see. Here we have beta provided. Based on beta we can create a relationship between I emitter and I base, because the equation comes like this: beta is equal to IC over IB. Therefore IC is equal to 100 IB, and to calculate I emitter there's an equation that is IC plus IB. Now IE is equal to IC plus IB, and we know that IC is equal to 100 IB plus IB, and that's going to give us 101 IB. Okay, this is I emitter. Now we have found out the relationship between IE and IB. Now what I'm going to do is I'm going to apply KVL right here. KVL in the first loop. If I apply KVL, this is going to be plus 5 voltage minus 10k times IB, 10k times IB minus VB is 0.7, and then minus this whole voltage, that is V sigma, that's equal to 0. Now we know that 5 minus 10k is 10,000 IB 0.7, and V sigma is basically 200, and the current passing through this is emitter current, so 200 times IE is V sigma, 200 IE, that's equal to 0. Now 5 minus 0.7, that's 4.3. 4.3 minus 10,000 IB and minus 200 times IE. Here we have two unknown variables. We have IB and IE. To make everything in one variable, we can replace this IE with 101 IB. That's why we created a relation in the beginning. So instead of this IE, I'm going to put 101 IB right here. That's equal to 0. Then if we simplify this one, this is 4.3 minus 10,000 IB minus 200 IB is equal to 0. So minus 200 IB is equal to minus 4.3. Therefore IB is equal to 142.4 microampere. Okay, this is the IB current. Now we had to find out what is the V sigma. V sigma is, to find out V sigma, 4.3 minus 10,000 IB, and we know that IB is equal to 142.4 microampere. So 4.3 minus 10,000 times 142.4 microampere, and this is 4.3 voltage minus 1.424 voltage, and that's going to give us 2.876 voltage. This is V sigma. Now we have calculated IB, V sigma, and the next thing is we have to calculate emitter collector current. To calculate that, we are going to apply KVL in the second loop. Okay, KVL in the second loop. I use a different color for that. KVL in the second loop. If I apply KVL in the second loop, this V sigma going through V sigma, then VEC minus 500 IC, minus, here we have a 12 voltage, that's minus 12 voltage, that is equal to 0. Let's continue this one right here, and if we write this one everything in terms of VEC, In the other side we are going to have plus 12, because here we have minus 12. If I move to the other side, that's plus 12. Plus 12 minus V sigma minus 500 IC. And we already know what is V sigma value. We just calculated right here. So 12 minus 2.876 minus 500 times IC. IC is, we have a relationship between IC and IB. IC is 100 times IB. We know IB is 142.4 microampere. So we just try to multiply that one with 100. So 100 times 142.4 microampere. Okay, then that is it. And then if we simplify this one, is 12 minus 2.876 minus 7.12. And if we simplify this one, it's going to be 2.004 voltage. That is a VEC voltage. And that's it. I hope you guys find this video helpful. Thanks for watching. And if you are trying to learn electronics too, there are a bunch of videos in my playlist. I hope you guys watch that too. And don't forget to subscribe. See you next time.